8.2 day 1 is graphing quadratics in standard form. We're going to spend 2 days on this. Today is kind of like rough draft graphs. We're going to learn all the vocab. We're going to talk about a couple of things, but we're not going to graph exact points just yet. We're going to do sketches. And it says that on here. It says sketch the parabola rather than like draw a nice parabola. We're going to see what that looks like here. So we're going to start with some vocab. Oops. Oh, that's new. All right. The first vocab here is parent function. The parent function is the most basic form that an equation can take that belongs to that function family. So, for example, the most basic equation that we can use to make a line is y equals x. That's going to make a straight line like so. You might have seen we did a couple other kinds of graphs. We've definitely done exponentials. It's been a minute since we did an exponential. But if it's like 1 to the x power, remember those made like J shapes? Do you remember those J's that we did? Okay. Then there was also, I don't know if we've talked about these ones yet, absolute value graphs. Y equals the absolute value of x. They make V shapes. So again, what I'm trying to show you here is that these parent functions create the shape. So for a parabola, the thing that creates the parabola shape is y equals x squared. That is its parent function. I can add and multiply and subtract and divide a bunch of stuff to this equation. But as long as I have that y equals x squared part, it's going to take the shape of a parabola, okay? When I add stuff to it, it's called a transformation, and that's what we're going to be talking about for the next couple days. We have also talked about this. This is standard form of an equation right here. So standard form, remember, goes from highest exponent to lowest exponent. So we have squared, we have x to the first, we have x to the 0th, aka no x. So that's all there. We are going to be taking apart these standard form equations and looking specifically at those coefficients and those constants. So in this equation here, I have 3 numbers that are going to be important to me. The a value is the very first number that comes right before the x squared. The second value is the b. B always goes with just x to the first. And then the last one, C. C is for constant. Okay, constants do not have variables. Any questions on that? So, for our sketches, there are a few things that we're going to look for. The first thing I'm going to help you figure out is where on my graph does my parabola go? And we have 3 different things we're going to look for. The first thing is the axis of symmetry. To figure out, based on an equation, what my axis of symmetry is, I use this formula. X equals negative b over 2 times a. That is a formula you need to have memorized. Why? Because it'll be on your quiz. So if I plug in my b value, my a value, I simplify it, I will figure out what x equals. X equals some equation. Then, once I figure out my axis of symmetry, the next part is to find my vertex. The axis of symmetry, let's abbreviate that, AOS, is the x value of the vertex. So if I have a vertex like so, x and y, I will take whatever I get from this formula and plug it in for x. That's the second part. The third part that's going to help me figure out where on my coordinate plane this graph goes is the y-intercept. The y-intercept is nice and easy. The x value, as we know, is always 0, and the y value comes from the C value. So whatever C is our y-intercept. Any questions on that? Okay. The next part that I'm going to show you refers to the shape of this graph. Those first parts are going to help us find the location. These things are going to help us find the shape. The shape of my graph all is dependent on that very first number, which is our A value. Okay? These first two sections here are going to tell us whether my A value is positive or negative. So for A greater than 0, those are positive numbers. If my A value is positive, my graph is going to take the shape of opening up, like a U shape. If A is negative, so that's A is less than 0, then my graph will open downwards like an upside down U. For the sketches in this example, no, it does not. So again, opens up. My vertex here is a minimum. This one opens down. And my vertex is the maximum. This is dealing with only the sign of that A value, positive versus negative. The next thing we're going to do is talk about the value, the absolute value of my A value, which is, I don't care what the sign is, okay? Just the number is what I care about here. So maybe I'm going to make a little note here. Disregard the sign. I don't care if it's positive or negative for this part. Okay, regardless of the sign. If the A value is greater than 1, so that's like if A is 2, -3, 4.5. If it's bigger than 1, then my graph gets really tall and skinny. This is called stretched. So really tall and skinny if that A value is greater than 1. I don't care if it's positive or negative. It's got to be greater than 1. The opposite, is called compressed. And this happens anytime my A value is between 0 and 1. So it's not necessarily all fractions, but oftentimes you will see these as fractions, decimals, but it's any fraction or decimal that's in between 0 and 1. 1/2, 2/3. 4/3 is not compressed because 4/3 is bigger than 1. So this has to be in between 0 and 1. We call this fat, and it looks like a big old wide graph that's been kind of squished and stepped on. Questions on this? So there's two different parts we're looking at. We're looking at the shape, and that all depends on that A value. We're also going to talk about some location stuff. So in this example, we are sketching. This isn't going to be an exact sketch. We're going to have to use our imaginations just a little bit, but I can determine some things for sure. When I start these problems, the first thing I'm going to do is label the A, B, and C values. So A is 2. B is 4, and C, this negative sign is going to go with that. C is -5. Okay, we're going to talk about just this left side column first. This talks all about the shape of my graph. So does it open up or down? I'm looking at the sign of that A value. A is a positive 2, so I know that this opens up. I'm going to write this little note so we know where we got that from. Positive. Then I'm going to do a quick little sketch just to help me remember. If you don't need this, then that's fine. But then I want to determine, is the vertex of this graph going to be a maximum or a minimum? Well, there's the vertex. It's at the bottom, so that means it must be a minimum value. The last thing we need to know about the shape of this graph is whether it's stretched, compressed, or neither. So now, I don't care if it's a positive 2 or a negative 2. I just care that it's 2. Is that stretched, compressed, or neither? If that number is bigger than 1, it gets stretched. So my graph is going to be real tall and skinny. Questions on that part? Here's the tricky part. Now we're going to talk about the location. Where am I going to actually plot this graph? The first thing is the y-intercept. What's the y-intercept of this graph? 0, negative 5. Perfect. The axis of symmetry comes from this formula right here, which is negative b over 2a. So I'm going to, off to the side here, I'm going to make a little axis of symmetry, a little bubble here. X equals negative b, so b is 4, all over 2 times a. Anytime I plug something in, it has to go in parentheses. So this is 2 times 2. And simplify this. 2 times 2 is 4. Negative 4 divided by 4 is negative 1. So my axis of symmetry is located at x equals negative 1. Everybody good with that formula? Again, formula you need to have memorized. The last part is to fill in the vertex. The vertex is going to be located. The x value is the axis of symmetry. And then I need to find the y value. Here's how we're going to do that. For the vertex, I'm going to take this original equation right there, and I'm going to plug my x value into that equation. So this will look like y equals 2. Look at how I'm putting this in parentheses. This is going to be important in a second. Squared plus 4 times negative 1 minus 5. Okay, this tripped up the last hour, so we want to make sure that we understand what's happening here when I do this multiplication. If I have a negative 2 times negative 1 squared, this negative 1 squared becomes a positive 1, but I still have a 2 out on the front. If this negative 2, if this is just a 2 with a negative 1 squared, like that, that's going to be a positive 2, right? Okay, so it all depends on where this sign is going. So if there is a negative in the front of this parentheses, then that negative stays there. If there is no negative in here, this is still becoming positive, even if there's a negative sign. So there is a difference. Let me show you one more. There is a difference between this and between this. Do you see what the difference between this and this is? This is negative 1. This is positive 1. Do you see? So we have to put these things in parentheses carefully. Okay, sorry, that was a lot of gibberish notes. So now let's simplify this. Negative 1 squared is 1. 1 times 2 is 2. 4 times negative 1 is negative 4, negative 5. And then I'm going to do my subtraction. 2 minus 4 minus 5 is negative 7. And that is the y value of this vertex. Okay, that was a lot of work. Now we just got to do a sketch. Again, using a little bit of imagination for this sketch, I need to be able to fit in my vertex at 1, negative 7. So let's try to put that in there at negative 1, negative 7. Let's say it's right there. I'm going to draw my axis of symmetry through that point. And then I'm going to put my y-intercept on 0, negative 5, which let's say it's right about there. Now let's think about the shape. It's got to be concave up. I know that vertex is a minimum. And it needs to look stretched. So I'm going to try my darndest to make this look skinny and tall. Any questions on that? I'm not going to make us do all of these on the next page, but you should definitely help me out here a little bit. I did all the explaining last time. Now I want you to help me with the explaining this time. The first thing we're going to do is label A, B, and C. What's my A value? negative 1. We don't care about the x squared. I just care about the number that's in the front. So that's like a negative 1 there. B value. You have a question? Oh. B? Yeah, B is 6. And C is 4. Perfect. Okay. Now let's talk about the shape. Does this graph open up or down? Down, because A is negative. Is it a max or a minimum? Draw a little sketch if it helps you. It's a maximum. And then maybe this is a trick question. Does this stretch, compress, or neither? This one is neither. So if there is, I'm going to erase this really quickly. If you get an equation and there's no number in the front at all, meaning it's a 1, then you have neither stretched nor compressed. Okay, that's the shape. Now we got to talk about where it goes. What's the y-intercept? You're whispering, but I can hear you. 0, 4. Axis of symmetry, we're going to use our formula. So that axis of symmetry formula is x equals negative, b is 6, over 2 times a. A is negative 1. Look how it's going in parentheses. And then simplify. Negative 6 over negative 2 is a positive 3. And then how do I find my vertex? We're going to take our original equation and we're going to plug in our x value. So this is, be careful here, look at where the negative is. The negative is on the outside. Negative x is 3 squared plus 6 times 3 plus 4. What does this first part simplify to? Oh, no, not an x. There's no x. Negative 3 squared simplifies to what, though? Positive or negative 9? Negative 9. This negative stays there. 3 is the only thing that's squared. So that 3 squared becomes 9. That negative just sits out in the front because it's not in the parentheses. Plus 18, plus 4. I believe this is a positive 13. Is that true? Positive 13. That sounds right to me. So my vertex is located at 3, 13. And I'm going to look at my graph, and I'm going to start putting things where they go. 3, 13 is like, I don't know, let's put it way up here for fun. Draw my axis of symmetry through that line. I have a y-intercept at 0, 4, so that's like somewhere over here probably. And then I look at my shape. It's going down. I got a max, and it is neither stretched nor compressed. So I'm going to try to make this as average Joe looking as possible. There we go. Questions on that? I'm going to do one more because it's weird. I'm going to skip this second one. Let's go to the bottom. We're going to start the same way. A value is what? B value is not 1. B value is negative 4. What's the C value? We don't have a C value. So when there is no C value, what do we think it is? 0. So you got to pay attention because sometimes you don't have a C value, but other times they try to trick you and they won't give you a B value. So you got to pay attention. Does it have a variable? Then it's the B. Does it not have a variable? Then it's the C. Okay, moving on. Almost done. Opens, up or down? Max or min? If it's opening up, then that's a minimum. Stretched or compressed? Compressed because that number is 1/2. It's between 0 and 1. Y-intercept? 0, 0. Oops. And then axis of symmetry, we're going to plug it into our formula. X equals Look at this. Negative, but b is already negative, so what do you think is going to happen to that? It's going to cancel out. It's going to become positive. So positive 4 over 2 times 1/2 is 1. That's just a 4. Vertex. We're going to take our original equation. This guy, there we go. This guy right here. I don't care about that plus 0. It wasn't there to begin with, so I'm not going to bother with it. Vertex. I want y equals 1/2. Look at how I'm putting this in parentheses all nicely. Squared. Minus 4 times 4. And I got to do order of operations here. So I'm going to square the 4 first. 1/2 times 16 minus 16. Again, order of operations. 8 minus 16 gives me negative 8. So my vertex is at 4, negative 8. I'm going to plot my first point, my y-intercept in the middle. I'm going to plot my vertex at 4, negative 8. That sounds about right. Maybe I should move it over a little bit, actually. And then what else do I have? Axis of symmetry. I know that the shape of this graph opens up and it's going to be compressed. So I'm going to do my best to make this look nice and wide and flat. Any questions? Okay. Homework's in your packet.